Hey everybody, Mr. Reeves back with you as we look at the addition and subtraction of rational numbers. In this video, we're going to stick with the addition of rational numbers, and then our next video we'll look at subtraction of rational numbers. So just a reminder, a rational number is any number that can be written as the fraction a over b, where a and b are integers and b is not equal to 0. And there are three ways that we represent those rational numbers: as decimals, like we see in problem number 1, in problem number 2, in problem number 6; as fractions, like we see here in problem number 3; as mixed numbers, as we see here in problem number 4. By the way, problem number 5 is an integer problem. Integers actually are rational numbers, but we usually refer to these as integers when they do not have any fraction or decimal parts to them. All right, so just a quick reminder, when we are adding numbers on the number line, if we want to go to the right, going to the right is when you, went up a little bit. All right, so that's when we add a positive. All right, since we're just doing addition, by the way. If we want to go to the left, let's see if I can make that one straight. That would be adding a negative. All right, and of course in our next video we'll talk about how you can move to the right by subtraction, or you can move to the right. I'm just going to leave it because I'm not having any success here. Move to the right by subtracting a negative, or you can move to the left by subtracting a positive. But again, we're going to be adding. And again, when the signs are the same, we will just get more of them. A positive plus a positive is just more positive. All right, and a negative plus a negative is just more negative. So adding positives to positives just goes further to the right. Adding negatives to the negatives just goes further to the left. Now, when you have positives and negatives together, then it comes down to what do you have more of and how many more do you have. All right, so let's just work through some of these problems and see what we come up with. All right, so for example, the first one right here, -3 plus -1.5, we would start on the number line at -3, and because we're adding a negative, we would go 1 and then a halfway right there, right? And where would that land us at? That would land us at -4.5. Again, when the signs are the same, we're just going to put them together. Number 2 right here, we are at 1.5, which would be right here. And then we're going to add 3.5. So 1 would get us right there. 2 would get us right there. 3 would get us right there. And then another half would get us right here to 5. So 1.5 positive plus 3.5 positive is going to be 5, or if you're going to write it as a decimal, 5.0. And again, if you wanted to do this the traditional way, we could do it this way as well. 5 plus 5 would be 10, and then we would carry the 1, and we would get 5.0 that way. All right, down here, I'm going to skip down here to number 5. 3 plus -5, I would be 3 on the number line. And because I'm adding a -5, I'd go back 1, 2, 3, 4, 5. In fact, let me just go ahead and draw that, okay? And I would land up at the number line on -2. If we were looking at this without the number line, we'd say, what do we have more of? We have more negatives. How many more negatives do we have? We have 2 more negatives. And finally, this one, number 6 right here, we're starting at -1.5. And because we're adding a positive, we would go 4 to the right. 1, 2, 3, 4 to the right would get us right there at 2.5. All right. Again, if we were doing this without the number line, we'd say, what do we have more of? We have more positives. How many more positives do we have? Well, then we would have to say, well, what is 4 take away 1.5? All right, and when we do that, we would get 2.5. Okay, so that's decimals, and right here we had integers. What about fractions? Now, when you add fractions together on the number line, you don't necessarily have to have a common denominator. 1/4 would be right here, by the way. This would be 1/4. This would be 1/2. This would be 3/4. There's 1. All right, there's 1 and 1/4, right? This would be -1/4. It's interesting they put decimals on the number line when they gave us a fraction problem, but we should be able to go between those without too much problem. So 1/4 is right here on the number line, and they want me to go up a half. Well, a fourth of a way, each of these markings is a fourth, so to go a half actually would be 2 lines right here, right? So I would end up at 3/4. Now, if we were doing this the traditional way with a common denominator, we would say, well, what do 4 and 2 both go into? They both go into 4, and I would change 1/2 to 2/4, right? 1/2 is the same as 2/4 right here. In fact, we could write it right here if we wanted to. There's 0, there's 1/4, there's 2/4, right? So the answer would be 3/4 because 1/4 plus 2/4 is 3/4. All right, now if you have a mixed number, again, all right, not too much of a problem. -1.5 would be right here. Do you agree? All right, so there's -1 and 1/2. And they want us to go -1 and 1/2 more. Since we're adding a negative, we go to the left. So there's a half right there, and there would be 1, and we would end up at -3. All right, and again, if you wanted to do this the traditional way without a number line, all right, normally what we would do is we'd say, well, 1/2 plus 1/2, that makes a whole, right? And then we'd have -1 plus -1 plus 1 more makes -3. Just a reminder, as we learned from the iReady, -1 and 1/2 means -1 plus -1/2, right? It doesn't mean a -1 plus a positive a half. That's not how it works. -1 and 1/2 means a -1 plus a -1/2. So if we put two of those together, this is where you see, right? That's -1, that's -1, and those two together also make -1, and we get -3. All right, so that's if you're working on the number line. Okay, if you're not working on a number line, you could do the problems just fine. Again, we've done a lot of these before. Putting things in parts together is an awesome idea. Also, finding zeros is also another way that's very helpful. All right, so if we take a look at this one right here, 1 plus 2 makes 3. Do you agree? And a half plus a half makes 1. So 1.5 plus 2.5, that's going to give us 4. So this problem comes down to -3 plus 4. Now we can go back up to the number line, and we could start at -3 and go 4 to the right and see that lands us at 1. Or we could say, what do we have more of? We have more positives. How many more positives do we have? We have 1. All right? Okay, what about if we come to a problem like this? Okay, so 2.75 is 2 plus, sorry, not 7.5, 2 plus 0.75. Do you agree? All right, and +2 plus -2 makes 0. Do you agree with that? When you add opposites, you get 0. So again, this was something we were learning in iReady, that I can then make those two equal 0. And now what do I have? Now I have a 0.75, right? That is positive, and a 5.25 that is negative. All right? So now here we have a little bit of an issue, because I really wish that were 0.75. That would make it so much easier for us. But this is -5 plus -0.25, right? And if we look at it that way, well, just these two parts here, do you see how that's going to give us a positive 0.5 when we put those together? I have positive 0.75 and negative 0.25. So when I put those together, then what that gives me is -5 plus a positive 0.5. And now you could see that this is pretty easy, because all I need to do is add that positive half to that -5, and I get -4.5, or -4.5. All right? So that's one way you can do it. Again, you can also do this the traditional way, all right, where you can line these numbers up with the decimals. All right, but the idea is these numbers are small enough that we can kind of work through this, putting together the positives and the negatives and the fraction parts without having it be too difficult. If you go down to number 13, this one's great, because there's positive 4.5 and there's negative 4.5. Well, those are going to cancel, and I'm just going to get negative 12. Again, opposites add to equal 0, right? If we go to this one right here, I have 12 negatives and 13 positives. Well, if I put those together, that's just going to give me a positive 1, right? Those two, what do I have more of? Positives. How many more do I have? 1. And then it's easy to add 8 and 1 together and get 9. All right, right here I have negative 4 and 1/2, right? Well, if we do this, that's negative 2 plus negative 2 and 1/2 plus positive 2. Again, this idea that we can break that up into its parts, correct? Why would we do that? Because that negative 2 and that positive 2, they cancel, and we get negative 2 and 1/2. You see how this works? All right, 1/4 plus negative 3/4. Well, negative 3/4 is negative 1/4 plus negative 2/4. Do you agree? All right, negative 3/4 is negative 1/4 plus negative 2/4. Well, those two are going to cancel, and I get negative 2/4. But of course, we want to simplify that to negative 1/2. All right. And how about this one right here? Negative 8 plus negative 1 and 1/8. Well, this one's really nice because they're both negative. And if you remember what I said earlier, a negative plus negative just gives us more negatives. So this one, we just put everything together and we get negative 9 and 1/8. All right? Okay, so there's some examples of fractions and mixed numbers and decimals. Again, the textbook is pretty nice in the values that they give you, that you should be able to break them up into parts and do some good mental math. All right, let's do a few word problems, and then we're going to be done with adding rational numbers. All right, Victor borrowed $21.50 to go to the theater. All right, when you borrow money, that is a negative. Okay, when you spend money, that is a negative. Okay. All right, a week later, he paid his mother $21.50 back. Well, that's a positive. He paid it back. Well, when you add those together, what do you get? Negative $21.50 plus positive $21.50 is what? 0. So how much does he owe her? He owes her 0. Nothing. Kind of a silly question, isn't it? He owes her nothing because he paid back the amount that he borrowed. If he had borrowed more, he would still owe her, right? If he had paid her back more, well, I guess she would owe him. All right, same thing here. She used her debit card. That would be a negative. Then she deposited. That would be a positive. And then since the absolute values of those are the same, that would be 0 as well. So they just wanted to reinforce that idea that when you add opposites, you get 0, which helps us in those earlier problems we were doing when we were grouping together. All right. Okay. Samuel walks forward 19 steps. How would you represent the opposite of that number? Well, the opposite of going forward 19 is negative 19. And again, when you add those, you would get 0. All right. Julia spends $225. That would be a negative $225 because she spent it. She earns $15. That would be a positive $15. All right. What is her profit? Well, the profit is going to be the difference between those two. All right? And $15, hopefully you know that if I take that $5 part of it, that's $225 plus $275. Did you guys know that? $225 plus $275. So I can write this as 10 plus $225 plus $275, right? You guys know $250 and $250 makes 5, right? $225. Well, why did I do that? Because that positive and that negative are going to cancel out. And what are we left with? $12.75 as a profit. All right, so a submarine is at this depth. It's a negative, okay? And then it dives. That means it goes down another 8.5. Okay, so I like these problems because it's a negative plus a negative. So we're just going to put those two together. And when you put negative 35 with negative 8, you get negative 43. And when you put that 0.25 with the 0.5, you get 0.75. So negatives added to negatives just give you more negatives. It was down, and it went down more. All right, so we ended up with a negative. Now, Renee hiked 4 3/4 miles, so she was going that direction. We'll go ahead and call that positive. Then she hiked back. All right, we're going to go ahead and call that negative. Okay, so we had 4 3/4 in the positive direction, and then we had 3 1/4 in the negative direction. How many more miles does she need to hike to return to the place where she started? All right, so again, if we look at this 4 3/4, that's the same as 4 2/4 plus 1/4. Do you agree? All right. Actually, let me change that. Let me change that. I don't like how I did that. All right, so 4 3/4. This is what I want to do. I want to change that to 4 1/4 plus 2/4. All right, what I said before wasn't wrong. I just like this better. All right, 4 1/4 plus 2/4. Why did I do it that way? Because 4 1/4 and negative 3 1/4, you see that's a difference of 1, right? So 4 1/4, that's equal to 3 1/4 plus 1. In fact, I like that even better than what I had written. All right, so I'm going to go back and change this. If I could get my eraser to appear here. I'm having problems. All right, I'm going to change all of this. 4 1/4, I'm going to change that to 3 1/4 plus 1 2/4. There we go. And that are going to cancel each other, right? So what's the difference? 1 2/4, but of course 2/4 is the same as 1 1/2. So she has 1 1/2 to go. All right, so that's how you add rational numbers. Again, rational numbers can be written as fractions, as mixed numbers, or as decimals. All right, I hope this helped. If you need more help, feel free to email me, and I'll be happy to help you some more.